Hello everyone, and in this video we are going to go over polynomial division. And what I want you to take away from this video is that polynomial division is very similar to normal division, and what we'll see in this video is the similarities between the two. So of course, in order to recognize the similarities of the two, we have to start off with a normal division problem with some integers. We're going to do the problem 346 divided by 23. Now, how do we do this? Using long division? Well, using the long division process, we know that this goes to, we put the 23 over here, or whatever our divisor is. We then write this, and we put whatever our dividend is over here, or numerator in this case. Our quotient will be up here along with any remainder if we have one. How many times does 23 go into 34? And we see that it goes one time because 2 times would make it in the 40s. So 1 times 23 is 23, and that gives us our 23 over here, which we then subtract. You see, if we subtract, we have 11 remaining, and when we bring the 6 down because 11 is too small, we try to figure out how many 23s can go into 116. So we see that 5 is a good option because 5 times 20 is 100, plus 5 times 3 is 15. So when we multiply by 5, that gives us the closest to 116 we can get, but just below, and that is 115. When we subtract, we get 1 left over, and sometimes we write that as 15R1. Now what I want to emphasize is that 15R1 is actually just equivalent to 15R1 is equivalent to 15 plus the remainder, which we can write as a mixed number. So 15 plus the remainder over the divisor, or the denominator, which is 23. So this is what I want to note here, that when we write the remainder is what we're going to add divided by the divisor of what our division problem was. So that's how we did normal division. And now we're going to see the similarities between this and polynomial division. So let's start off with a relatively simpler polynomial division problem. X squared plus 4x plus 4 divided by x plus 2. And how do we write this? Well, we'll just consider x plus 2 like we did over here, and our numerator like we did over here. So very similarly, we're going to write our x plus 2, and then we're going to write our x squared plus 4x plus 4. So what was the first step we did in this long division process over here? Well, since 346 was pretty large, we decided to stop at maybe the 2 digits because we have 2 digits over here. Similarly, what we're going to do here is we're going to stop at 2 terms because we have 2 terms over here. So if we take this x plus 2 and try to figure out how many x plus 2's go into x squared plus 4x, one of the best ways to do this is simply cancel out the largest degree term. So if we want to cancel out this x squared term, that means whatever we multiply to this number, to this entire number over here, has to result in an x squared term. So whatever we multiply, let's say we multiply x, if we do x times x plus 2 in total, then we have x squared plus 2x. And of course, we're going to subtract that like we do in our long division process. And the key here is to remember that we want to always match the coefficient and the degree of this term with whatever we are dividing by. So for example, since we had an x squared term over here, we wanted the coefficient to be 1, which we have over here. And we wanted the degree to be x squared, which is x squared because we have x times x, and that'll be the largest term. So when we subtract this, these cancel, and we get 4x minus 2x because the negative distributes, and we're left with 2x. Now I like to bring the other term that we have left down, and we see that since we want to match up the coefficient and the degree of the term, well, the degree is already the same, so we won't need to multiply an extra x. What we do instead is now match the coefficient. And since the coefficient is 2 here and 1 here, we can multiply 2. So remember, this is very similar to what we're doing over here. So we do x plus 2, because when we multiply 2 times x, we get the same large term over here. So 2 times x plus 2 in total will be 2x plus 4. We then subtract this, and we see that this cancels out with this, and we are left with 0 as our remainder. So our final answer is x plus 2. And you may have recognized that because it was a perfect square trinomial. But now let's move on to a slightly different problem. X cubed plus x squared plus 4x plus 4, and we're going to divide all of this by x plus 2 as we did before. Now how do we write this? X plus 2, and then we write our x cubed plus x squared plus 4x plus 4. So now what do we do here? Well, again, we want to match up our x cubed term with our x term. The coefficient of both of them is 1, so we won't have to multiply any constants. So what we have left to multiply is the degree to match up. So in order to match up the x cubed and the x degree, we need to multiply by x squared. And it's a good sign that your starting term of your quotient, when you multiply it to the starting term of your divisor, that'll match up to the starting term of the dividend, or the largest term in the dividend. So let's multiply this out. When we multiply x squared times x plus 2, then we get x cubed plus 2x squared. And we subtract all of this, and we see that we cross out x cubed, and we are left with x squared minus 2x squared, in which case we get a negative x squared. And this is perfectly okay. You may not see a negative here. Polynomials are separated by terms, as in here we would just borrow to the previous number instead of leaving a negative. But we can't do that in this case because the terms are different. So anyways, let's go back to this. So negative x squared we are left with, and I like to bring down how many terms there are in our original divisor, which is 2. So now we have to match up coefficient and degree. So x, what are we going to match up the coefficient? Well, we have to multiply by a negative 1. So I'll put a negative there. To match up the degree, we have to multiply by x. So negative x times x is negative x squared. Negative x times 2 is negative 2x. And this is the key part. Remember, we have to subtract all of this. Now these will cancel out because they're the same. Now 4x plus 2x, because the negative distributes, will be 6x. And then of course I like to bring down this 4. So now we have 6x plus 4. Now it's the same number of terms, and we want a same degree as well, so we have to match up the coefficient. The way we do that is we add the 6 over here, so 6 times x plus 2 will match up the coefficient, and that'll give us 6x. And then we have 6 times 2 is plus 12. And we're going to subtract all of that. And that'll give us 4 minus 12, which is negative 8. So we have a remainder of negative 8, which looks really weird. But the key here is that, as we said before, this remainder is kind of deceiving. It looks like the negative 8 is the same degree as the 6. But the problem is, we can actually write this as x squared minus, what is this, x squared minus x plus 6. And instead of the remainder of negative 8, as we saw here, in order for that to be a number, or a mixed number in this case, we have to divide by the divisor. Divide the remainder by the divisor. So that means we have to divide the negative 8, and I'll keep the negative on the outside. We have to divide the negative 8 over the divisor, which in this case is x plus 2. And now we see why the negative remainders are possible. There's no way we can combine this denominator with any of the terms here without making it an entire fraction. And if we had made it an entire fraction, you'd see that that is exactly what our result here would be. That our first question. If we made a common denominator to all of these terms, then we would get exactly what we have over here. So this is our answer for that. And there's two ways we can write it, with the remainder of negative 8 or like in this form. So now let's move on to an even different example with more terms. And this time I'll write it directly in this form. Let's say we're dividing a polynomial that's not a binomial, which can be a little weird because we're used to dividing by binomials, as we've seen in the last two problems. But in this case, let's try dividing by a trinomial. And we'll do x squared plus x plus 2 as our divisor, x to the 4th plus 3x cubed plus 2x squared plus x plus 1. But let's do what we've been doing before. So, in order to match up the largest term with this largest term, the coefficient is the same, so the only thing we have to do is multiply x squared. When we multiply by x squared, we get x squared times x squared is x to the 4th. X squared times x is x cubed. X squared times 2 is 2x squared. We are going to subtract all of this. We see that the x to the 4th and x to the 4th cancel out. The 2x squared and the 2x squared cancel out. And we're left with 3x cubed minus x cubed, because the minus distributes. And we have 2x cubed. Of course, we have to remember that this 2x squared plus 2x squared cancels out. So the next term I'm going to bring is the x. And I'm going to write that over here. So again, if we want to match up the 2x cubed to the x squared, we're going to have to match the coefficient in the degree, which will result in 2x. Now 2x times x squared is going to be 2x cubed. 2x times x is going to be 2x squared. 2x times 2 is going to be plus 4x. We're going to subtract this. The 2x cubed and the 2x cubed cancel out, and we have negative 2x squared. And then x minus 4x, which will be minus 3x. Of course, I want to match up the number of terms, which we have negative 2x squared minus 3x plus 1. And again, we're going to match up the coefficients because the degree is the same. Multiply by negative 2, and that's all we need. The degree is the same. So negative 2 times x squared Move this a little down. Negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. Again, finally, we are going to subtract all of this. And these two cancel out. The negative 3x plus 2x, the minus distributes, will be negative x. And we see that 1 plus 4, because the negative distributes as usual, will be plus 5. And that'll be our remainder, which we can write here as remainder of 5 minus x, which is equivalent to negative x plus 5. And of course, as we've seen from the previous problems, we can write this as x squared plus 2x minus 2, and we have our remainder divided by the divisor, which in this case is x squared plus x plus 2. So this is how polynomial division is done, and as we'll see, the polynomial division process can really help when finding the roots of a polynomial, and especially because in the next video we'll explore a technique that allows us to divide a polynomial by a binomial in a much easier way than doing long division.